Good morning, dear children. In this video, we will continue to learn how to solve numericals of chapter number 11 of physics. The name of the chapter is Work and Energy. Four examples we have done in our previous video. So in this video, we will start from example 11.5. So let us read the question. The question is this: find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground. Given g is equal to 9.8 meter per second square. So whenever anything is above the ground, it is at a certain height, then in this case the work done, that will be equal to potential energy. So basically here we are to calculate potential energy, and for potential energy the formula is mgh. So mass is 10 kilograms and h is 6 meters, g is 9.8 meter per second square. So put all the values, and when you will solve it, you will be getting answer equal to 588 joules. So potential energy is 588 joules. Now let us go to example 11.6. An object of mass 12 kg at a certain height above the ground. It is present at a certain height above the ground. If the potential energy of the object is 480 joules, then you have to find out the height at which the object is with respect to the ground. So basically you are to calculate h here. Mass is given, then energy is given, g is also given to you, it is 10 meter per second square, and you are to calculate h. So here you have potential energy, the formula is mgh, and potential energy equal to 480 joules. M is given, it is 12 kilogram, g is 10 meter per second square, and h you have to calculate. So upon solving, we get h is equal to 480 divided by 120. So it will be 4 meters. So height will be 4 meters. Then we have example 11.7. Let's go to that example and learn how to do it. Yes, 11.7. Two girls, each of weight 400 Newton, climb up a rope through a height of 8 meters. We name one of the girls A and the other B. Girl A takes 20 seconds while B takes 50 seconds to accomplish this task. What is the power expended by each girl? So in this case, you are to calculate the power expended by girl A and power expended by girl B. So power is work done upon time taken, and here work done, that will be equal to mgh because they are climbing certain height. So work done, that will be equal to potential energy, and the formula will be mgh. So let us start with the solution. Weight of first girl, it is 400 newtons, and you know formula for weight is mg, so that's why it is written here mg is equal to 400 newtons. And how much is the displacement or the height of the first girl? It is 8 meters. Time taken is equal to 20 seconds. So power will be equal to work done upon time taken, or it is mgh upon t. You put all the values, and if you will solve it, you will be getting power is equal to 160 watt. Similarly, for the second girl, the weight is same, so mgh, that is same, mg is same, mg is equal to 400 newtons, and in this case displacement is 8 meters, and time taken will be 50 seconds. So power is equal to mgh upon t. So put values of m, g and h. M is 400 newtons, mg is 400 newtons, it is weight 400 newtons. H is 8 meters, so mgh upon t, and here in this case power comes out to be 64 watt. So in first case power is 160 watt, in second case power is 64 watts. Then we have example 11.8. After this, there is a boy whose mass is 50 kilogram and he runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, then you are to find out his power. Again, the formula for power will be work done upon time taken, and work done will be equal to mgh here in this case. So let us start. Weight of the boy, mg, that will be equal to mass into acceleration due to gravity, and mass is 50 kilogram and acceleration due to gravity is 10 meter per second square. So multiply this 50 with 10, you are getting 500 newtons. Height of the staircase, h, and this h will be equal to it is 45 into 15 by 100 meters. Now how come it is written here? There are 45 steps and height of each step, it is 15 centimeter. So what we have done, we have converted this 15 centimeter into meters. So it is 15 by 100 meters, and number of steps, it is 45. So that's why it is written 45 into 15 by 100 meters. So we are getting 6.75 meters. So this is the total height attained by the boy. Time taken to climb, it is equal to 9 seconds. So power, the formula will be mgh upon t. Mg is 500 newtons, h is 6.75 meters divided by 9 seconds, and you are getting answer equal to 375 watts. So this is example 11.8. Now we have the last example of the chapter. The last example is about the energy consumed. So you are to let us read this question. An electric bulb of 60 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the bulb. So formula for energy is power into time. But here you know that commercial unit of energy is kilowatt hour. So power should be in kilowatt and time should be in hours. Here in this question, power of electric bulb, it is given in watt. So calculate this watt into, convert this watt into kilowatt. How to convert? 60 divided by 1000. So we are getting 60 by 1000. It will be 0.06 kilowatt, and time, it is given in hours. And that's okay. We are not going to change the units because we need answer in kWh, kilowatt hour. So energy will be power into time taken. Power will be 0.06 kilowatt and time taken is 6 hours. So multiply these two, we are getting 0.36 kilowatt hour. And as you know, 1 kilowatt hour is known as 1 unit. So we have written answer as 0.36 units. So the energy consumed by the bulb is 0.36 units. So that's all with the examples of this chapter.